right? 60 plus 80p cubed plus 10p. For this factoring equation, we need to find the GCF, the greatest common factor. The greatest common factor is what every number can be multiplied by, or what can be divided by and equal a whole number. So we need to find the greatest part of that. So since they're all just in a set of 10, so the greatest common factor would be 10. So then it would be 10 times 6 plus 8p cubed plus p. Because all this is divided by 10, and then after doing that, because the objective of factoring is to simplify it as much as you possibly can. So after this, you can't really simplify it much at all. So you get 6 plus 8 p cubed plus p, so all these, and you put the greatest common factor in front of it. So whenever you multiply it again, it's like 10 times 6, 10 times 8p cubed, and 10 times p, it all equals 60, 80p cubed, and 10p. Put all of these together, plus 60 plus 80p cubed plus 10p. So this is what you get when you factor your equations. This right here would be your final answer. Alright, let's try a completely different one. Alright, we have r squared minus 16 minus 16. So this is called difference of squares, and it's because these are both perfect squares and the difference. And the way you do this is, again, you kind of have to square root this, but since it's negative 16, it's not really possible to get an exact square root. So you have to do r, because this is the square root, and then you have two different equations that have r and 4 in it, since 16 or 4 equals the square root of 16, and r equals square root of r squared. So since we're multiplying it together in the end, it's going to be r plus 4 and r minus 4, because it's going to be r plus 4 times r, and then r plus 4 times negative 4. So you're going to get over here negative 4r minus 16, and you get over here r squared plus 4r. So when you put those together, r squared plus 4r minus 4r minus 16, these two cancel each other out, so then it just becomes r squared minus 16. This would be your final answer, since it's the difference of squares.